My name is Terence, and I'll be your host for this session. So before we start the session, can I invite everybody to please put your phones and mobile devices on silent. We will also be having a question and answer session after this talk. So for those who are tuning in online, you can type in your questions into the chat box next to the video. Be sure to enter your questions into the chat box in the correct track, because there are two sessions that are happening concurrently. Please make sure that you choose the right one. For those who are here physically, you can also choose to scan the QR code to ask your questions, or you can approach the mic at the center of the room to ask it. Okay, so without further ado, please help me to welcome our speaker, Professor Chandra. Professor, please.
Good afternoon, everyone. Is the sound system okay? Are you able to hear me well? Wonderful. Let me just give a very quick introduction of myself. How do I get my slides up? Click. Okay, so that's the first slide. And yeah, let me do a very quick introduction of myself. Chandrasekhar is my name. I'm a professor in the Department of the Built Environment in the College of Design and Engineering at NUS. Again, if you look at my own interest and my own, shall we say, research and teaching interests over the last 3+ decades, 30 over years that I've been in NUS, it's been in a field that all of us, in one way or the other, we can relate to. We live in buildings. This is a room in a building. We call this the Suntec City Convention Center. And no matter where we are, at any time of the day or night of our life, we are in buildings. We call that the built environment. Now, what's built environment? Anything where you have an environment that you are adapting yourself to, or the environment adapts itself to serve our needs. We say we spend more than 90% of our time indoors. Just reflect on this point. In our life, more than 90% of our time, we live inside buildings. We also make this point that almost like 30 years, between 25 and 30 years of our life, we are probably spending in some kind of sleeping environment where we sleep, we rest. So buildings play a very important part. No wonder then my title today, the talk I'm going to give today, is called Sustainable and Resilient Healthy Buildings. Now the word sustainability or sustainable, I think, has been used a lot. It means a lot to all of us. We can have our own definition. I'll give you a perspective that we use in our curriculum, in my research, in our group's research. And the word resilient is another important word that all of us have begun to appreciate since the COVID-19 pandemic, right? So we had to adapt ourselves. We had to be resilient. It comes in so many different ways and different forms, and in different contexts too. And the word healthy buildings. I think the word healthy buildings, again, it goes back to saying that if you stay somewhere in a building, in a built environment, or if you are traveling in a bus, if you're flying 12 hours somewhere, it's another enclosed environment. We want that environment to be safe. So you'll see in my talk some maybe heading towards what professionals like architects and engineers would do, but also some things that we can relate to. We need a good, comfortable environment. We need a safe environment. And that's the context in which this particular title is presented. So what are the grand challenges when it comes to built environment? Climate change. We are hearing about it almost every day these last few years, right? Population growth worldwide. There's this rapid urbanization that's occurring right through every part of the world. Resource demand. There's enough, some people say, some would argue, there's enough around, as long as we make good use of it, the resources. But we also have to manage the demand for these resources. Take energy, for instance. We could do with a lot of energy for a variety of purposes, but unless we use them in a judicious manner, we're going to waste it, and it is, in that sense, quite limited. So we have to be mindful of what we use. So demand of the resources is another big challenge that the world is facing in today's context. And then I mentioned buildings, I mentioned built environment. Some of the words that you see here, they are related to what we need to drive this whole notion of a good, safe, comfortable, quality built environment. Sustainability, without saying, we have to make sure that we don't waste resources, we do not have an impact, adverse impact on the environment, inside and outside. Cities and communities, and I think we can relate to that. Districts, neighborhoods, rapid urbanization in different parts of the world. People are coming to cities for making use of the resources there. Then comfort, well-being, and health. And this is a word, again, that I'm sure a lot of you would be quite aware of and relate to. When you go into a building, you feel comfortable when you are nice, and you don't feel that you have to fan yourself, or you don't feel too cold. In some other climates, one can go into a building and they feel very cold. And it's also the case of where you are, your health is not adversely affected, because sometimes in the buildings there could be certain contaminants that can potentially not be very good to us. Energy use. This room right now is using some amount of energy for the lights, for the air conditioning, for the projector, for whatever resources that we need inside this room. There is energy consumption that is required. And the word human centricity means that we design buildings, we operate buildings because of us. If you and I don't have to be in this room, I can turn off all the lights, turn off the air conditioning, you save energy. The resources will be completely maintained. Nobody's going to use it. But society is such, life is such, we are people, there's lots of people on this planet, we are in different climatic conditions, we have to create environments where we can adapt the environmental conditions for our needs, and vice versa. Sometimes we have to adapt. You go into a city where it's very cold, you wear a jacket, so you adapt yourself, keeping yourself warm that way. Now, high-performing buildings basically means that a building that is going to perform to meet all the needs. It makes people comfortable, makes them remain healthy, and it does not consume too much energy. So sustainable and resilient, healthy buildings is another concept or notion that we talk about in the context. Now let me wear the hat of a professional, an architect, or an engineer, or a designer. In the context of buildings, we call that an integrated design and operation. In other words, we got to make sure right from day one, from the start, that the buildings are designed properly and they can be maintained, operated and maintained in a sustainable manner. So you see all these kind of buildings, photos, right? City skyline. You look around here, when we step out, we see all these buildings. All these buildings, before they got to the shape that it is in, it starts off with something that we call, on the right-hand side, a concept. Somebody, an architect, a designer will say, okay, I want to think in terms of this building appearance in a certain form and shape. So it starts from concept design of the structure, of how it's going to look physically. Then the way the resources are going to be used, what kind of lighting I'm going to have in the building, how am I going to manage the elements from outside, the sun, the wind, the heat, and all those sort of aspects. So the building facade, what we call the facade of the building, is made of glass, it's made of walls, or it is made of glass and walls, all of which has an impact on how the energy consumption for the building can take place. So that's where the high performing or the high performance aspect comes in. So as designers, as architects and engineers, as a professional community, our objective is to design a high performing built environment, or buildings, let's say, that can take care of people's needs and consume the least amount of energy. It's not easy. We've been trying to do that for decades, for centuries, I would say. And then we make positive steps, we make improvements, And today, if you hear this term called zero energy building, how many of you have heard the word zero energy building? Anyone here? Zero energy building? I'm sure you must have heard it, right? It's there in the news media all the time. People talk about it. So what's zero energy building? Zero energy building. A building that can meet all the needs that I've been talking about and does not consume any energy. Wow, that's magic, isn't it? How can that be? So the question that we ask ourselves is, how can you design and operate a zero energy building? Today, we know that we can harness the sun's energy. In Singapore, that's a very easy way that we can think about solar energy. If we can produce electricity, harness the sun energy to produce electricity, then you produce enough electricity for your needs, so the building's energy consumption is literally zero. You're not getting energy from the grid. No fossil fuel is burnt anywhere to produce the electrical energy needs, and that's what we mean by zero energy building. So these are all some of the ways in which we can move forward with the requirements and how we want to do it. So who are the key players in this domain? All of them. Let's just reflect on each one of these boxes. Just think about what role they play. Designers, these are the architects, the engineers. They know what it means to have a sustainable design. They know what it means to have an energy efficient building. Then you have the owners. I mean, they own the building. They are the ones who are going to fund the building as it is being designed and constructed. Then there are contractors who actually build it. This building just doesn't appear in the form and shape it is just because someone designed it. Somebody has to build it, make it. So it is a process. The industry is well geared towards that. There are people, the contractors, who make these buildings happen in that sense, the physical form and shape. And then you have the operators of the building. These are the facilities managers who will operate the building in the most efficient manner. And what's a simple example of efficiency here? If a room, like this room right now is being used, so you need the lights, you need the air conditioning, but if you don't need it, can we just not use them? That's resource management, resource usefulness, right? And then, of course, the regulators, the codes, and other building regulation that we need, so that we stipulate that you can't have a building that's overly consuming energy too much, or it's not fulfilling the needs of the people, the comfort requirements, and so on. So there are regulations that come into play. And then, of course, the users and occupants, all of us. We have a role to play. We will decide how we want to operate the building. We will say, do I need to keep this building so cold that every one of us sitting here wears a jacket? That could be one way of being in a building. The other way is that all of us are lightly attired and we are quite comfortable. I'm quite comfortable. Are you? Are you comfortable? Are you feeling cold? Are you feeling hot? It's just nice. So the facilities management has done a reasonable job in ensuring this room is comfortable. So that's a role FM teams play, right? Now, I use this slide in all my lectures, whether it's undergraduate or graduate level. I can talk on this slide for 2 minutes, 5 minutes, 1 hour, whole day long. Which format would you like today? We don't have too much time. Let me try and do the 5-minute job, right? So this is the fundamentals of any building design. We call this passive design and active design. Now, the word passive means that there is no direct energy use. I'm not consuming electricity in that first left-hand side boxes there. Just by placing the building in a certain way, orientating it, simple logic will tell us, if I'm going to have a building that's 20, 30 stories high, a lot of glass facade, and if my glass is not facing east or west, that's a good thing to have. I'll reduce the amount of heat coming into the building. That's known to architects, that's known to engineers. We maximize the performance, passive energy design. We say, let's optimize the passive design features of a building. The orientation, the facade system. Would you want to just use any glass that lets in a lot of radiant heat? And this is very easy to understand. We know, simple example, if you have to go and get into a car that's parked in an open car park in the hot sun, I'm sure when you open the door, you can't quite get in. It's too hot inside. Why is that? A lot of heat, the solar heat has gone in. It's like basically all the heat build up over there, right? A glass box, a glass container, greenhouse gas, just kind of trapped gas, trapped heat inside that compartment. So we want to maximize the way the building facade can help us. So can we think in terms of materials that won't let too much heat in? And there are materials that can reflect the heat away, not too much of solar heat comes in. This is passive design. You have not used any energy yet. You not used any electricity, no air conditioning yet. On the left, we are still on the left-hand side, passive design. Window-wall ratio. The words explain what it means. In the wall facade, 30-story high wall, in Singapore, let's say we typically have floor-to-floor height or floor-to-ceiling height of 3.5, 4 meters, 30 meters, 30-storied building. We're talking about 120 meters high. 120 meters high facade wall. If you put everything glass, a lot of heat goes into the building. We want to try and minimize the amount of heat, but you can't just put walls that you don't have a view out. So these are all the architectural elements that we need to understand and incorporate into the building. So how much window, how much wall has a role to play? And it's a passive energy design optimization. Glass properties. There are materials of the glass that can cut down the solar heat by as much as 60 to 70% of the heat of a typical glass. There are ways in which we can manage all of this. So an architect will design and ensure that the selection of materials, the choice of how you want to orientate, how much window you want to put on the wall, with all this combination, you can design a building that's already very efficient. That's passive design optimization. And then you say, okay, we come on the right-hand side, the active design, I need lights in because I can't expect lights in the night. There's no sunlight in the night. If it is cloudy, I can't get the light. So you need artificial light, these kind of lights. And then you go for the most efficient lighting system. That's where the artificial lighting comes in. Then you have the air conditioning system. The second and the third boxes on the slide, on the right-hand side, HVAC is heating, ventilating, air conditioning. The systems and plant, that's the air conditioning system, it has an impact. So air conditioning system will have tremendous impact, and in Singapore, some of the buildings, we can even say that the air conditioning consumes almost like 40, 50% of your total energy consumption. And we want to do something about that. And now, this is not a forum where I talk about how to design very efficiently, but yes, you can design and operate the systems very efficiently. Operational efficiency means the FM, the facilities manager, how they operate the building. Reducing the waste. When you don't need air conditioning, don't use it, and it'll cut down the energy consumption. All that comes in over here. So that was a very quick way, probably 3, 4, 5 minutes of discussion on this, and we can always have an elaborate discussion on it at an appropriate time, and that's what we also do in our curriculum in the university. Now, I put this here as new buildings, totally from scratch, the architects, engineers, no constraints. Now, we have a lot of buildings that are already built 20, 30, 40, 50 years ago, existing buildings. With existing buildings, you can still apply all of this, but some of them are constrained. For instance, a building that is facing in a certain way, I can't change it unless I demolish the building. It's impossible, right? Window-wall ratio, probably another difficult thing to do. You can't take the entire window system and put a new one. Actually, if you want, you can do that too, but then there are constraints and restrictions in how much is possible. Okay, now in Singapore, we have the Building and Construction Authority who actually have this green mark scheme. It was first kind of started here, initiated here in Singapore in 2005. So we are, about 18 years now, 10, 18 years. In the 18 years, we have made tremendous strides, done a lot of, I would say, positive enhancement to the energy performance of building. So the green mark scheme is the it is the rating system. It's a kind of measure, environmental impact measure in more ways than one. We don't have time to go into details of it, but here is a snapshot of what it is doing. In 2004, we had 0% green mark rated buildings. 2005, the very first building, the National Library Board headquarters building on, it's not too far from here, that tall building. That's the first building that was green mark platinum. And then over the years, that's the growth. That's the positive direction in which we have moved. And as of end of last year, 55% of our buildings have been greened or green mark certified into some level of rating system. Our target is by 2030, 80% of all buildings in Singapore must be green mark certified. That's our target. That's what we are aiming to achieve. So here is the, if you're interested in the link and go and read a little bit more about it and find more information, there's the green mark. The current version that we are using is the green mark 2021. Super low energy buildings, we constantly strive to improve. Super low energy buildings means that the design is so optimized, you've taken into account all the various possible permutations, combinations of reducing energy, improving the performance. You make it even more efficient than what is the highest rated building, say green mark platinum, then it becomes a super low energy building. And within the super low energy category, we have the zero energy building. I mentioned the zero energy building earlier. The building produces enough energy by itself for its needs, that zero energy building. We have the Singapore Green Plan 2030. Again, something you must have read in the news, heard in the media. And there is something about buildings or built environment. Here you see 80% of buildings green by 2030. Then we have 80% improvement based on the 2005 level. That means another indicator based on 2005 energy performance. We want to make even better than that. And then we say 80% of all new developments to be super low energy. Our targets are, they're ambitious, but they are practical. We can achieve them. We have been doing that over the years, and we try and do it in a way where the industry as a whole can rise up in its performance standards. And that's a good thing to happen when we let the whole industry gear up towards what the performance requirements are. Heating, ventilating, air conditioning systems. Air conditioning is my field. I do a lot of work in this area in relation to systems and how it impacts thermal comfort, indoor air quality, energy consumption. So it's a very big sort of impact in the field of what we call the sustainable and resilient healthy buildings. You see all those words in the second box here, airborne infection risk mitigation. Now, during the pandemic time, there was some concern. In fact, we knew it was always the case that the infectious aerosols can actually spread through the airborne route, and the air distribution system can play a role. So you have to manage how that can be better controlled. You got to clean it, filter it, get more dilution of outside air to remove the contaminants. All those things come into part of what we design in the building system. So let me move a little bit fast over here. Two things I want to highlight in the context of built environment: building resiliency during pandemic times and building resiliency during haze episodes. You see, I mentioned 90% of time we live inside buildings. What happens on the outside environment, we still have to be experiencing that in some way or the other. If the outside environment is polluted, a lot of the parts of the world right now has been facing serious outdoor pollution problem. We too have faced in the past. And you also hear in the media about haze, likelihood of haze in the next few months because of natural environmental conditions outside. It's called the El Nino effect. The heat buildup, and then you have a very dry season. There could be potential concerns of outdoor pollution because of fires and those sort of issues. Something that we face, how do we manage that indoor? So as building designers, as people who look after the built environment, we have to ensure that we are resilient enough. The building is resilient enough to handle those kind of requirements. I have this slide about ventilation standards. If you understand the need of ventilating the building, you take air from outside, clean it, of course. It could be polluted. It will be polluted. We've got to clean it. And then if we have to flush the building of the contaminants, be it any kind of contaminant, including aerosols, infectious aerosols, you need to have ventilation air provided there. Up until now, we have not had what we call health-based ventilation standards. We advocated that during the pandemic time. This is an article from Science that I and some of my colleagues were part of in an international community, scientific community. We made the point that you need to have better handle on how ventilation is provided, more ventilation when needed, cleaner air when it is needed, and you had to be able to manage that on an as and when needed basis. That straight away introduces the word of resiliency. The system has to be designed in a resilient manner. It has to be able to operate in an as and when needed basis. Sure enough, ASHRAE, this is an international society based in the United States. It's a professional society, a technical society, and it's about air conditioning systems and built environments, energy consumption, comfort, air quality. I'm quite actively involved in this society. ASHRAE, 53,000 members worldwide. Just last month, about 4 or 5 weeks ago, produced the standard called ASHRAE 241. That's the number of the standard, control of infectious aerosols. So this is the standard that's now available for the entire world if the designers and engineers were to refer to what they should do to make sure that their building design is resilient enough to handle a pandemic response. That's what this standard is about. So you see the built environment as a sector, as an industry, as a field of engineers, professionals. There's so much that we do for society. It's a society at large. It's not just to produce something, but it is something that we all experience in our day and life, every day of our life. Right, I will probably have to move this a little fast just to give you some snapshots of pictures. This is the net zero energy building in NUS. It's called the SD4 Building. It's part of my own college. It's just 20 meters from my own office, which is in another building. It's a zero energy building. We designed it as a zero energy building, commissioned in 2019 January. Zero energy means you don't consume energy. Guess what? Last year, it became even better. It became energy positive. Wow. Wow, right? This building is now producing more energy than it needs. Now, that's the ambition. That's the ideal. That's the target designers, engineers, we are striving to achieve. Of course, when you use renewable energy, that means you're not touching the fossil fuel, you're not polluting the environment. So you are actually doing something that's good for the environment, not having any demand or any constraint on the fossil fuels. That's the way the future is going to be. There'll be more and more of zero energy buildings built in the future, more and more energy positive buildings built in the future. I'll skip that slide. There's some concept of how this building achieved that zero energy concept. We changed the notion of air conditioning. In this building, guess what is the temperature that we maintain? 27 degrees inside the building. It's air conditioned. We have fans. So 27 degrees with ceiling fans or pedestal fan. We have ceiling fans in the building, arranged and designed and installed as per original plan. It creates nice, comfortable movement that people are very comfortable about, and they like it. And no wonder when we manage it the way it should be, you're also able to save all the energy that we produce and becomes energy positive. I'll skip all this data because these are scientific data, and I'm sure if those of you are interested, this might be made available to you through whatever means the organizers are thinking about. You can read some of the details, and there are publications as well about these. Look at this right-hand side slide. We save about 26 to 30% energy. See, it's not only comfortable, not only it's making, and that's why it's energy positive now. It's energy plus, because we have been saving energy on a very regular basis. And in this building, we also provide a lot of outside air for ventilation. It's also like clean air quality that we are providing into the building. That's one slide I just showed you. What about existing buildings? These are photos from different parts of the world that I have been to for conferences and elsewhere. I like that environment, that city skyline. Take a photo just to show and say that buildings, wherever they are, old buildings, we still need to make them energy efficient. We can. Existing buildings can also go towards energy, zero energy building. So in our same college, whilst I showed you a new energy positive building now, 45-year-old buildings, two of them, SDE1 and SDE3, we renovated it mostly during the pandemic time. Of course, we were not occupying those buildings, so it was being renovated, refurbished. Again, the same thought process, designers, architects, engineers thought through the whole thing. What can you do in existing buildings? And today, I can say this again, SDE1, the building that's shown as SDE1, is a zero energy building. 45-year-old building can now be operated as a zero energy building. So it is possible to convert an existing building also into a zero energy building. That's what it is over here. You see, this is how the old building looked like, the one that became a zero energy building, SDE1, not different from SDE2. And by the way, my office is in SDE2. So that's why I said 20, 30 meters from this building, those other efficient features that we just spoke about. Okay, I'm going to skip through all of this photo just to say how they are, where they are in the campus. Come to the last couple of slides, just to sum up in terms of my main messaging here. If we are thinking about existing buildings, it's doable. As you can see in this slide, we worked on that SDE 1 and 3 by improving the facade. So the window system in the old building, 45-year-old design, was quite poor, leaky. We removed the entire window system and went in for more energy efficient panels. Good glazing material, good window material, good panels, no leaks, that kind of a design feature. Then what we call the innovative air conditioning system, maintaining it at 27 degrees. No, we did not recycle any air. Most of the air conditioning system will be recirculating the inside air from the building. In our building, we do not recirculate. We just use 100% outside air. So final remarks, high-performing buildings, what does it entail? All the things the designers, engineers, thinking through in terms of how to make it efficient, thinking through in terms of the comfort and air quality requirements. You don't have to make it work the same way all the time. Make it resilient, make it adapt nicely as and when you need. You have a pandemic response, activate the pandemic mode. You have a haze issue, activate the haze episode issue or haze resilient issue, mode of operation. We can do that. All these are doable. And it goes back to integrated design and operation. You have to think about it in the design stage. Otherwise, it's very difficult to achieve that in operation. Sustainable and resilient healthy buildings, people must be aware. The design must be innovative. Adaptability, resiliency, that's where the word comes in. And flexibility in operation. Pandemic mode, resilient, haze mode, normal mode of operation. Use it when you need it. All these are words that we can very nicely relate to. Now, this is my last slide to talk about the program that we have in our department, in our college. It's called the Master of Science in Building Performance and Sustainability. It's a 1-year full-time or 2 years part-time program. All the things that I spoke about in this short half-an-hour presentation, we go in-depth into the curriculum. We go in-depth into the actual content, the details of it, right? We go through in a manner that the graduates, once they leave the program, they serve the needs of the industry. They are part of what I would call the team that is on here in Singapore, and for that matter anywhere in the world, to drive home what we believe in as green buildings, sustainable and resilient, healthy buildings. Thank you for your attention, and I'll be happy to take any questions that you may have, any sort of questions. Thank you.
Thank you, Professor. So as we mentioned, now is the Q&A session. So if you have any questions that you would like to ask Professor Chandra, now's your chance. So maybe let's just start off with 2 questions asked by the online audience.
Okay, what will be considered a relevant discipline for admission to the MSc BPS program? Good question. We have architects, we have engineers in the program. Typically, I would say 40%, 40%. So it's like half, slightly less than half for each of this. And then we also have other engineering related background like civil engineer, mechanical engineer, building engineer, architectural engineer. It's all the background that's in one way or the other got to do with the built environment industry or built environment sector. I hope that answers the question that is being asked.
Okay, maybe we can show next question. Yep, your session was fantastic. How do you address the climate extremities in developing nations? What architect model would you like to see in buildings?
Yeah, I think the question is probably there to each and every one of us, irrespective of where we are. We are part of a community, we are part of a society, we are part of a city where we know buildings are going to be built. They're either already there or new buildings are going to be built. Built environment, city skyline, this is going to happen. Rapid urbanization that I spoke about earlier. So if the mindset of all of us who are part and parcel of this particular vision or aspiration, if we say that we want to build a district, the district itself must be sustainable. It must be designed in a manner that it reduces demand, reduces waste, reduces energy wastage, resource wastage. So all the things that I spoke about earlier just now from the building point of view, the built environment point of view, the physical building, materials that are used in the building, the energy consumption for the lights. If we design the building in such a way you don't need to use artificial light during the daytime. Imagine that this room was in the what we call the perimeter zone of a building. Actually, it is, right? Is there a window behind? I believe there is window behind. So if we can make use of daylight, they don't need this artificial lights, at least at this time. It's quite bright outside. So how to harness the daylight into the building? Our zero energy building, the one that's now energy positive, there will be no need to use artificial lights during daytime. The windows are orientated in such a way, it's also protected from direct sun in such a way that you get the light in but not the heat in that sense. So I think there are ways by which if the vision of a sustainable design is there in the minds of all of us who make such a thing happen, I think it's an achievable, it's a common goal, it's a common aspiration. It is not somebody's aspiration to make somebody else's needs being fulfilled. It's a collective vision. And I think that's why it makes the entire field so, we can all relate to it. Everyone can relate to it. You don't have to be an engineer, you don't have to be an architect. You still have a place to go to that you call your house. You still have a school that you go to and say, I'm being educated here. You have a building that you go and say, I work in this building. If you look at what's common in all of that, it is a building. And each and every one of that space, if we can make it more efficient, that's the way to go. Think about it, COVID-19 pandemic, we were asked to work from home. What does that mean? You're still working, not in your office building, but at home. So your home is your office. Would you not want to make your home an efficient office home environment? And it is an area we had not given too much thoughts to. Residential buildings were not given much consideration up until recently when we say that if you spend more time working from home, your home has to be more efficient. Think about it. So I think it's a collective vision, it's a common aspiration for all of us, and we had to think along those lines. I hope that answers that question there.
Maybe at this moment, I would like to ask if there's any questions from the floor. Anybody wants to ask a question for Professor Chandra?
Feel free to come up to the aisle mic.
Okay, maybe they need some time to process their thoughts as well. So let's move on to the next question, which is, what are the career prospects for this program?
Right. I love this question. I love this question because the answer is very simple. It's bright. It's absolutely bright. In Singapore, I say Singapore Green Plan 2030. You look at the whole world, there are green buildings being designed, being conceptualized everywhere, smart buildings, smart city. Smart city, an important component of smart city is the smart built environment. Buildings that are built, constructed. There's so much career prospects in all of these. And I think common aspirations, common goals. We only have one planet. And I suppose the key messaging here is, it's not what I do here in this country or in this part of the world. It's affecting the whole world. I think that's what we need to think about, right? The kind of floods, drought, hurricanes, fire, haze, outdoor pollution. I think I mentioned quite a few of them already, earthquakes. It's not confined to what is happening in one part of the world. It's happening to the entire planet. And collectively, we need to understand certain things we have a control of. We can minimize the demand. And built environment has a very direct role to play in terms of how much greenhouse gas is emitted. I didn't speak about the greenhouse gas emissions, but when we talk energy, that's what it is. You consume more energy, you're emitting a lot more greenhouse gas, CO2, into the atmosphere, into the environment. So we can control it that way. So the career prospects of this program, the graduates of this program is, in my view, very bright. And we see that happening all the time. I'm not only talking about here in Singapore, it's throughout the entire world. There is a need to make more and more green buildings, more and more efficient buildings, energy positive. There are targets like we want to make, by 2050, all the buildings that's going to be built has to be zero energy building. There are targets in several parts of the world along those lines. So it is, simple answer, as I said, is it is very bright.
Thank you, Prof. Okay, so let's move on to the next question. Could you elaborate a bit further on how a building can be?
Right. So a building can be for a building to be energy efficient, you have to reduce the demand in the first place. So if I can reduce my air conditioning demand, already it's a step in the right direction. If I can reduce the energy consumption for lighting, step in the right direction. So let's reduce the demand, and that's what we mean by the passive design optimization. You remember that slide I said, passive design, active design? I can speak for a whole day on that, as I said. So we have to address that, reduce the demand. Once we reduce the demand, we have to consume energy for what it needs, because you need energy, right? You need air conditioning at some time of the day or night here in Singapore. In cold climates, you will need heating because it's extremely cold, okay? Unless you're going to wear thick jackets and jumpers all the time, that's not always very practical too, right? So we reduce the demand and then produce the energy for that consumption, for that demand, in the most renewable manner as possible. So if we don't consume fossil fuel, then fossil fuel based energy, like the electricity that we get at home, typically it's from a power plant which uses fossil fuels, so it is not a green energy in that sense. But if I have enough photovoltaic solar panels on my building, produce enough electricity from the solar energy, all my building energy needs are fulfilled by that solar energy based electricity, then it is zero energy. Demand met by renewable energy, zero. Now if my building produces more energy, that means I'm producing more than what I need. The excess, you pump it into the national grid. That's what we mean by energy positive or energy plus. In Singapore, typically it's the solar energy based, solar panels, photovoltaic electricity. In some other countries, They can produce it by other means. They can produce it by wind power, where the conditions are amenable for wind-generated electricity. Some other countries, it could be geothermal. You make use of the heat from under the ground and produce your you see, if you have enough heat, you can use that for good purposes, good needs for us. So geothermal can be another renewable energy to produce for the energy balancing equation. So there are different ways. That's what I meant. A building can be energy positive.
Okay, maybe we'll move on to the next question. Other than environmental aspects, what are some of the digital aspects in an environmental building?
Right. So this is something that I probably did not have much time to elaborate on, and that's the future. You see, in the context of operational energy, like I mentioned about this building right now, this room, it's comfortable, it's not too cold, we're just nice, all of us are comfortable. If, let's say, in the next half an hour we vacate this room, I'm assuming that they will turn off the lights, they can control the air conditioning, maybe even turn it off, then it saves energy. So in the past, yes, buildings always had an element of control, building controls, automation control as you call it. But if we can incorporate that with user interface, like all of us sitting here, if we could, in the first 10 minutes here after being here, say the place is too cold, you have an app, you input information into it, it can be taken by the building management system, and they can say, oh, this environment is feeling too cold. The occupants are telling me to do something about it. I can change the air conditioning to make it a bit warmer. That's using data, real-time data from the ground when it is being operated. And this is now, I'm not just making a statement, it's not a false claim, it's not just a bold claim. Data-driven management, collecting data from people, from sensors, can save energy anywhere between 20 and 30%, operational energy. Think about it. You have already made the design optimized for passive elements, passive features. You then produce the energy in the most renewable way. And now, if you can operate your building so you save on all the active energy requirements by data collection, by using artificial intelligence protocols, machine learning protocols, you understand what's the pattern of energy consumption, minimize waste. Basically, I'm saying minimize waste. If a room is being overcooled than what it should be, that's wastage too. I mean, that's absolutely wastage. Why should I maintain this room at 21 degrees Celsius and expect every one of us here to wear a jacket? That's not how, I mean, step out, you want to be in your t-shirt. That's how the outside environment is. We adapt ourselves based on what is outside. Again, the use of information from people, data collection. That's the future. That's how it's going to be. So data collection, real-time data collection, using that to operate the building systems is the future. And as I said, you save energy, operational energy, you make the building better for people's needs. It's more than just the environmental aspects. You are using today's technology for better operation and management of the buildings. And not just one building. You can do it at a district level, city level, across all the time, across all the levels. Okay, I hope that answers that question. Yes, we have had civil engineers in our program, and certainly civil engineers do come with a little bit of a notion about environmental engineering impact. So civil engineers, the building, the physical building is all about civil engineers who make it happen. It takes certain form and shape in the physical sense because of civil engineering. Building can be constructed. It has to be constructed in a certain way first. Civil engineers are the ones who make that happen. Yes, so we do have civil engineers, and a good number of them are very much plugged into what it means to have a sustainable building, a high-performing building, very much part of the community.
Okay, so can I ask if there's any questions from the floor?
I would like to answer this question. Green building often costly to build. I would say, well, it's probably in the minds of a lot of people. It doesn't have to be. It really doesn't have to be. When you design buildings where you reduce the energy consumption at the demand reduction stage, passive design, where, I mean, maybe you're investing in some building material. Now think about it, that material of the facade or the window panel is there for the next 30, 40, 50 years. When you apportion it, the cost over time, first cost, maybe. Even then I would argue it need not be. But if you do a life cycle costing over the life of a building, it pays itself times over. And I think it's an argument that really needs to be understood as to where the thinking is coming from. If you say it's costly to put what we call a low E, a double glazed window panel, yeah, those windows are costly, no doubt. But then it saves about 80%, 70 to 80% of your solar heat. And you save it for the next 30, 40, 50 years. And the calculations will show up. Life cycle costing will show up. So it need not necessarily be a costly building. You have to look at it in the life of a building, what we call the life cycle costing analysis.
Okay, maybe I will ask, maybe we can have one last question before we wrap up this session. So once again, invitation to
Any
the
last
floor
question?
if anybody wants to ask a question.
Maybe I'll ask them a question. How about that?
Please go ahead.
How many of you are interested in this program next year? I would encourage you to consider what I've been talking about. This is something that's very close to my heart, not because I'm running the program or I've been teaching on the program, because every person on this planet Earth today has to ask this question: am I wasting resources? What am I doing to save the wastage of materials in whatever form? We didn't even talk about use of plastics and use of bottles and all those kind of things. We can go back to those discussions and also say that has an impact on the environment. So ultimately, I think what we're really talking about is the way of life. To me, it's a way of life. So if we believe in this, and if you are a professional in this field, and I'm sure you'll also think along the same lines, that it is something that we all have to do collectively. It's not just one person doing for the rest. All of us have to play a part. So I do encourage you to consider the program seriously, and if you are the professional that you would like to be part of this very exciting, interesting profession and the future game that we are all in, I look forward to seeing your applications next year. And thank you for your attention, and I think that's probably time up for me. Thank you.
Thank you, Professor Chandra. So that concludes our session. We invite you to share your views on the event as well as the presentation that you just saw.